Okay, in this one, so you're going to find sine 75 degree. There are two ways you can do this problem. One is, you can say 75 degree is 45 plus 30 degree. Then you can use this formula over here, sum of different formula. So you can take that approach, or you can do double angle approach. Double angle mean or half angle, whatever. 75 degree you multiply by 2, you get what, 150 degrees. So 150 same as what, 180 minus 30. So you know the value of 30. So what is sine 180 minus 30? So you can take that approach using the half angle formula. And here's the other one, cosine 75, the same way. And sine minus 210 degree, that's same as sine is an odd function, negative sine 210. That is same as sine 180 plus 30. So that's same as what, sine is sine in the third quadrant, first, second, third quadrant. So it's going to be negative, negative. So it's become plus sine 30. All right. Now we need to work on 11 pi over 12. So you can use that double angle approach. So 11 pi over 12 is same as 11 pi over 6. That's one way of doing it. Or you could do like a sum of the difference of two angles. So 11 pi over 12, that turn out to be, but you can break it like a pi plus the pi minus pi over 12. Then after you get pi minus pi over 12, that is so then you can use sine, but it's pi minus pi over 12. That's going to be sine pi over 12. So that's one approach. Or I said double angle, that's another way. So here I'm showing you lone pi is all second quadrant. So sine lone pi over 12 is positive. So it's positive. So in the double angle formula you had to know it is a plus or minus. So here it is plus. So that's the way to decide it is plus or minus. So here I'm going to show you how to write pi over first of all you have lone pi over 12, that's same as what, pi minus pi over 12, and that is same as then sine pi minus pi over 12, it's going to be sine pi over 12. So now you need to know what is pi over 12. You have to break into two difference of two angle. So I came up with that idea, how about something like 4 pi minus 3 pi over 12, 4 pi over 12 minus 3 pi over 12. So that gives you pi over 12. So here what you could do is that's same as 4 pi over 12. You just divide both top and the bottom by 4 in the 4 pi over 12. That become pi over 3 minus 3 pi over 12 become divided by 3, you get pi over 4. So now you have difference of two angles. You already know those angles, pi over 3, pi over 4. You can use the formula up there, sum and difference formula, and simplify the problem. Okay, tan pi over 12, you can do the same approach, that's same as what, pi over 3 minus pi over 4. So you could get that one done. Okay, cosine 17 pi over 12. So how you going to do 17 pi over 12? That one you can break like what, pi plus 5 pi over 12. That's one way. Then what is cosine pi plus pi over 12? Okay, I'm going to write there pi over 2, 5 pi over 12, and so then cosine pi plus 5 pi over 12 is same as it's in the third quadrant. It's a negative cosine 5 pi over 12. So then 5 pi over 12 we have write some form like a difference of two angles. So I think I'm going to come up with something like a 8 pi over 12 minus 3 pi over 12. So you had to play with these fractions. 8 pi over 12 minus 3 pi over 12. That's going to be, so divide again by 4, you get 2 pi over 6, 3, minus divide by 3, you get pi over 4. Okay, so 2 pi over 3 minus pi over 4. So you can use that formula, cosine u minus v formula. Same way, tan pi over 12, you can do the same way, I break it pi over 3 minus pi over 4. Alright, this problem I had done earlier, cosine 75, I saw you one way is difference. Now here you can use the double angle approach, so it's a straightforward. One thing you need to be careful, like it's a plus or minus, so depend on the quadrant, decide it's a sine or cosine. Alright, so I'm going to work on this identity. Secant x is 1 over cosine x minus sine x over cosine x times sine x, and you simplify denominator cosine x, 1 minus sine squared x, cosine squared x, Pythagorean cosine x over cosine x, that's same as 1 over secant x. So this problem, you do the same thing. Secant theta, you write 1 over cosine theta, and tan theta, sine theta over cosine theta, and cotangent theta, you write cosine over sine. Okay, I made a mistake because cotangent theta had the cosine theta over sine theta, so I wrote it other way around, so I need to fix the problem. I need to erase that. So it goes like this. So instead of sine theta on the bottom, it's going to be cosine theta. And sine theta go on the top. So that becomes, so you have a denominator cosine squared theta, so you get 1 minus sine squared theta over cosine squared theta. So that's same as this one. Similarly, you can do the rest of the problem. So whenever you see a tan, you say sine over cosine, or when you see a secant, it's going to be 1 over cosine, or cosecant, it's going to be 1 over sine x. And this kind of thing, you can simplify and get the answer. So here's 1 plus 1 square root of 1 minus sine theta, 1 plus sine theta. This comes from the half angle formula. Look at the formula somewhere there. So I did this couple of problem here. I think I had done earlier. It's cosine 75. This is from the notes of the book. So I write here notation like a method 1, method 2. So I write M1, M2. So that means method 2, half angle approach, 11 pi over 12. So I wrote like that, pi minus pi over 12. Alright, let's do this one. Tan 43 minus tan 13 over 1 plus tan 43, and tan 13, that's same as what? Difference of tan, that's tan 43 minus 13 degree, that is same as tan 30 degree, that is square root of 3 over 3. So rest of them you can use those formulas to figure out how to simplify. So here what 12 is a cos and the plus sign in between, so that's going to be the formula what cosine u minus v. So you have what cosine 5 pi over 12 minus pi over 4. That's going to be alright. 5 pi over 12 minus pi over 4, so you have to find the common denominator. That's going to be 12. 3 pi over 12, 5 pi minus 3 pi is what 2 pi over 12. That is same as pi over 6. So you know what is cosine pi over 6? That is cosine 30 degree. That is square root of 3 over 2. So similarly you can solve all the rest of the problem. So the 17 is what? That's a tan a minus b formula. So that's same as what? Tan 2 theta minus theta. That's going to be same as tan theta. Oh, here's I give you a problem. You know how to solve 5 sin x plus 2 equals sin x. So you have to solve for all values of x. So the difference between all values and O, other one you see number 13, they ask you the range 0 to 2 pi, but here all values. So you had to get the general pattern. So 5 sin x minus sin x equal to negative 2. You just add negative sin x, negative 2 both sides. You get sin x equal negative 1/2. So now you need to find the reference angle. What's the value of sine? That sine is going to be 1/2. That is going to be pi over 6. That's the reference angle. But here this negative, sine is negative here, sin x. So it's going to be the third quadrant and the fourth quadrant. So if it turn out to be in the third quadrant, it's going to be pi plus pi over 6. That is going to be 7 pi over 6. Or if it is in the fourth quadrant, it is 2 pi minus pi over 6. That's going to be 11 pi over 6. So here the sine is periodic with period 2 pi. So that's why you have x equal 2k pi plus 7 pi over 6. Other one 2k pi plus 11 pi over 6. And remember, tan is periodic with period pi. If it is pi, if it is tan, you will get k pi plus that angle, So if you look at number 13, so the sine the 4x plus 2 sine squared x minus 3, this is like a quadratic equation. You solve for sine squared x, then get the solution. Okay, I just put all the double angle power reducing formula, half angle formulas here, and so here you need to understand which formula to use for which problem. So I just put 75 degree, that's you can use double angle formula, half angle formula, pi over 8 you can use, and 3 pi over 8, 7 pi over 12, or if you want you can use the difference of two angle. So you need to play that trick. I think like I prefer difference of angle. It depends how you good with those numbers. Okay, I have a couple of problems here. Square root of 55, 1 minus cosine 6x over 2. So you need to figure out which formula to find. Okay, so we are going to go to the left hand side and see where the square root of 1 minus cosine something. So that's going to be the number one formula in the half angle, that is sine u over 2. So if you want to use that formula for number 55, what you have to do is you set u equal to 6x. So you need to find what is u over 2. That is 3x. The answer is plus minus sine 3x. 56. Okay, 56, that is 1 plus cosine, square root of 1 plus cosine 4x over 2. So therefore, the formula is going to be the second one, cosine u over 2 equal plus minus 1 plus cosine u over 2. So you plug in u equal 4x, you get plus minus cosine 2x. That's the answer for number 56. Number 57 is weird. It is minus 1 square root of 1 minus cosine 8x over 1 plus cosine 8x. That's going to be the formula under power reducing formula. That is in number 3. That's tan squared u equal 1 minus cosine 2u over 1 plus cosine 2u without the square root sign. So you substitute 2u equal to 8x in that formula. U equal to 4x. So now, forget about the square root sign, just take without sign, so tan squared, you use that 4x equal to 1 minus cosine 8x over 1 plus cosine 8x. Now you solve for tan 4x, is going to be plus minus 1 minus cosine 8x over square root of 1 minus 8x over 1 plus cosine 8x. Okay, that's all I have today. This pretty much cover everything,